Problem 4, consider the differential equation dy dx equals 2x minus y. Part A, on the axes provided, sketch a slope field for the given differential equation at the 6 points indicated. So first of all, I'm going to just go point by point and find the slope. So the first one I'm going to do is 0, 1. So if my x is 0 and my y is 1, I will get 2 times 0 minus 1, which gives me negative 1. So my slope at 0, 1 will be negative 1. Okay, and then 0, 2. My slope will be 2 times 0 minus 2, which will be negative 2. So it's going to be a little bit steeper. And then I'll do 0, negative 1. 0, negative 1. My slope will be 2 times 0 minus negative 1, so that will be plus 1, so my slope is going to be 1 down there. So I'll try to make it the same as that one, just opposite. 1, negative 1, my slope will be 2 times 1, that's a negative 1, plus 1 again, so that's going to give me 3, so my slope there is going to be pretty steep, so it's going to be a slope of 3. And then at 1, 1, my slope will be 2 times 1 minus 1, which gives me 1. So I'll try to do the same as that one down there. And then 1, 2, my slope will be 2 times 1 minus 2, which gives me 0. So that is my slope field. That was worth 2 points. If I found where my slope was equal to 0, which was just at one spot, I'd get a point just for that part right there. And then the slopes, they're just looking for where did I get a slope of 1, which would be at those 2 points, I get another point. So I guess they didn't care about the other ones. Okay, for part 2b, find d squared y dx squared in terms of x and y. Determine the concavity of all solution curves for the given differential equation in quadrant 2. Give a reason for your answer. Okay, so if I'm looking for this, this is the second derivative. Okay, so if I take the derivative of dy dx, that does give me the second derivative. And then on the right side, the derivative of 2x is 2, minus the derivative of y would be 1 dy dx. All right, they did say they'd like their answer in terms of x and y, so we don't want to keep that dy dx in there, but we know what dy dx is. So our second derivative will equal 2 minus the quantity 2x minus y, and if I simplify that, that will be 2 minus 2x plus y. Okay, and then that from there, we're not done because it says to determine the concavity of all solution curves for the given differential equation in quadrant 2. So if I'm looking for the concavity on this one, I would look at in the second quadrant, quadrant 2, all of my x's in quadrant 2 are going to be negative, and all of my y's in quadrant 2 are going to be positive. So if I plug in a negative x, this part will always become positive, and if I'm putting in a positive y, this will always be positive. So 2 plus a positive will always be a positive number. So my second derivative is always going to be positive or greater than 0. So if I'm determining the concavity of everything in quadrant 2, I will just say that all solution curves will be concave up, and I will say because the second derivative is going to be greater than 0 for all points in quadrant 2. Okay, I would get 2 points for this one. I'd only get 1 point for getting that second derivative, and then I get 1 point for saying concave up and y. All right, part C. Let y equal f of x be the particular solution to the differential equation with the initial condition f of 2 equals 3. Does f have a relative minimum, a relative maximum, or neither at x equals 2? Okay, please notice that it doesn't say to find the particular solution. It just says that y is the particular solution. So this is not one where we get to cross multiply quite yet. What we would like to do is, if I'm looking for a relative minimum or maximum, I need critical values. So I need to see if there's a critical value at the point 2, 3. So to find a critical value, I'm going to be finding dy dx at 2, 3. And if I do that, I'll get 2 times 2 minus 3. That gives me 1. So there is not even a critical point at the point 23, so there cannot be a relative minimum or a maximum. So I'm going to say neither, and I'm just going to say because there is not a critical value at 2, 3. And I might even say because dy dx is equal to 1, it doesn't equal 0. Okay, so that would be worth 2 points. 1 for considering that I am considering my derivative and not getting 1, and 1 for saying neither with a justification. All right, part D. This one is just, I don't care for this one because, once again, we don't have to cross multiply. This one, it says to find the values of the constants m and b for which y equals mx plus b is a solution to the differential equation. So they are telling me right flat out here that this is a solution. So they don't want me to solve it. They don't want me to cross multiply. They're just straight out giving that to me. So we know that y equals mx plus b is a solution. So we're just going to try to find a couple things from here. If I have y equals mx plus b as the solution, then y prime, its derivative, m and b, it already told me they are constants, so the derivative of mx plus b would just be m. And then if I took the second derivative, the derivative of m, since it's a constant, would be 0. So let's see if we can use that to try to figure out what m and b are. Okay, so the first thing that I'm going to do here is y prime. We know that y prime is the same thing as dy dx, so one thing that might help me here, I know that 2x minus y would equal m then, if that helps me at all. And then y double prime, we actually found what y double prime was. Y double prime equaled 2 minus 2x plus y, and we know that is equal to 0. So doesn't look like this is going to help me too much. Well, actually it does, because if I know that m is equal to 2x minus y, I can put that in there almost. If I factored out a 2x, notice that would be the same thing. So now I know that 2x minus y is equal to m. So I know that 2 minus m would equal 0, so m would have to equal 2. So that helps me out, and let's see if I can from there find out what my b would be, excuse me. To do that, I'm going to do something kind of tricky, and you might not have noticed this. I'm going to solve this for y. So I'm going to get y equals 2x minus 2. So we actually already found out if this is the solution, because all of a sudden I found that, we're just going to match up the m and the b. The m would be 2, the b would be negative 2 to get that to match up. So this was a really tricky problem, so would not be surprised if you didn't get any points on it, but hopefully we could get something from it. This was worth 3 points. If you at some point in time acknowledged that the derivative, the 2x minus y, was equal to m, you got a point. If you said that the derivative of y equals mx plus b was equal to m, you got a point. And then if you were able to find your m and your b values, you got that 3rd point.